So in this last part of the workshop, I will show you what to do with the imported images in Lightroom and how to find out about your diffraction limits. So I have imported these full aperture images. When you see here in the image details, I have aperture 2.8, 4.0, 5.6, 8, 11, 16, and then 22, 32. What I will do with these images is I will grab a first image. I will go to the develop module in Lightroom, and I will actually apply lens corrections and color corrections for this lens. Lightroom automatically finds the right profile for this, and then I will do a very small crop in the image on a part that I have focused on. The crop should be as small as you can make it, more or less. So we get a part of the image, a very small part of the image, and then I will select all images and I will synchronize these corrections on all images. So what I have used is lens corrections and crop, and I will synchronize that to all the other images. And then of course I have to wait till the preview is updated on all these images before actually being able to compare the results of one image compared to another. I will go back to the library in Lightroom, and I will use the comparative viewing mode. So if I make my screen as large as possible, what I get here is from top to bottom, from left to right, the image series aperture 2.8, 4.0, 5.6, 8, 11, 16, 22, 32. And what I can notice here is that at f2.8 my image is not having the sharpest results, but when closing down the aperture one stop and then two stops, my image actually gets sharper, and then it stays reasonably sharp for one or maximum two, although I have the impression that I already have some image quality loss at f11, and then the image quality goes all the way down over 16, 22, 32 to actually a very bad image quality with a total loss of detail and a total lack of contrast in for instance these black letters. This is not due to the lens quality in any way. This is purely the effect of diffraction. So the light rays getting spread open on a wider array of pixels than the pixel they actually should land on will give me these horrible results at an aperture of f32. So what this shows us is that you should, if not needed, you should avoid using your aperture at a too small setting because of diffraction. You might want to optimize your depth of field to cover foreground to background in a landscape image, but take into account that an aperture that is closed down too far will always lead to sharpness loss and contrast loss. So this is it for this workshop.
I hope you've learned something about diffraction, so don't forget, never close your aperture too much or you will lose sharpness, you will lose contrast. I want to thank Cambridge in Color for their research on photography topics and for their clear explanations on different subjects. If you want to learn more, please visit the rest of their website. I'm sure you can get something out of it. Bye bye, see you next time.